This conference will now be recorded.
Okay. Okay, so welcome to the third of the Babcock Mathematics Research Talks. I know some of you have attended before. Thank you for coming back. Some of you are new to them. So just very briefly, we started these last term, and we're hoping that this is going to be something that sort of runs and runs. We wanted to give an opportunity for anybody to share mathematics research they've been involved in that's maybe of quite a small scale and may not get to a wider audience. It's not a heavily funded bit of research, but a little bit of research that they've done, but they think actually has relevance and interest to others in the maths education community. And it's to kind of provide a platform for that. So far, we've been sharing bits of our research, but I'm hoping other people are going to suggest they might like to do one of these talks, and we would host it for you. And then we're popping them all on YouTube afterwards for people to access outside of the live event. Today's mathematics research talk is going to focus on a research project that we've had running for 2 years around understanding structured number lines, and I'm going to talk about that for around 40 minutes, and then there'll be a chance for sort of questions and things at the end. So the project we set up was in response to growing evidence from various places that pupils in England were not developing an understanding of the structured number line, and that had then had implications for understanding mathematics across several domains in the national curriculum. One of the places that information was coming from, that evidence was coming from, was the IMAPS project, and certainly a catalyst for that was a presentation that Jeremy Hodgen did at BITME 9, which was sort of part of the way through the work of IMAPS. And this is the project where they were looking at low attainment in mathematics in year 9. And the report from this research project has been published this year. So we now have some sort of final words around this. So they're looking at low attainers in year 9 and their understanding of mathematics, and also the teachers of year 9 students. And I've picked out this bit here about the use of representation, and a little bit here about number lines. So teachers were positive, although there was a lack of consistency in the way that they used representations and manipulatives. Many pupils reported finding number lines confusing and were unfamiliar with arrays. And I think for those of us in primary, we might be surprised at both of those things, because number lines and arrays are representations that we use a lot at different points during the primary years. And so to have year 9s that are confused by number lines and unfamiliar with arrays might surprise us, but that's one of the things that they found. And so this comes from their research, and here's some of the assessment questions they used. And at the top one there, if you just have a little look at that. So what they said was many pupils struggled to answer that question, or they needed considerable assistance to do so. And then if you just look at question 2, because that's a calculation question, but it has within it an understanding of the number system and ways to think about numbers that might enable you to answer it. And again, very few pupils approached it by means of a number line and bridging through 10. Most opted for a column addition method. And I think you're going to see that replicated with our research. I want to hold on to this, what they've put here about that they didn't approach it by means of a number line, because I want to be really clear about what our research focused on. And I'm going to come to this in a couple of slides, but we were not focused on children drawing number lines to solve questions. That was not what we were doing. And I'll pick up on that in a moment. And then this is just another little bit from their report. Most pupils reported they didn't use number lines much. They didn't like them, either finding them too difficult and confusing, too slow to draw, or believing they were too simple. So there's a whole mixture of things going on there for these year 9s, but generally they do not have a positive attitude and they do not have a deep understanding of the number lines. So I sat in on Jeremy's session at BICME, and I kind of went, I sort of understand where that comes from, because I've met so many primary children who do not understand the structured number line. And so it's no surprise to me that you have children coming into secondary that are confused by them and don't understand them and don't like them. So we set up this project, and as I said, it was not focused on using number lines to do things such as calculate, and it was not about the empty number line. So there's a lot of research around the empty number line, and many of you here will be very familiar with it. And I know Alison Borthwick's with us today, and she's done research around use of the number line, and particularly things like empty number line calculating and things like that. We were not looking at that. We were focused on understanding structured number lines as a way to understand the structure of the number system. And then what we I hypothesized, I guess, was that if they had that understanding, if children had that understanding of the structure of the number system, and that was supported through their understanding of structured number lines, that would in turn support understanding in other areas such as measurement, statistics, and calculation. So we were interested in building that understanding so that there was the understanding of the number system, but also that then fed into other parts of the number system. So when we're talking about structured number lines, it's probably a good idea to just be really clear about what we mean by that. So I'll just give you a moment to read this slide from Dietzman and Lowry. So it's very much this measurement model, understanding the number line as a measurement model. And that was sort of became quite a key way of thinking about this as we worked with teachers through the project. So that we're thinking about the distance from 0 when you're thinking about a number and placing a number 3. That point where number 3 is telling you about the distance from 0, and it's that measurement model. It's important that with anything, any manipulative, that we hold on to this, that the number line itself is not the content. So we weren't focused on, we just need children to understand number lines for the sake of understanding number lines and using them. It's what does that give us? What understanding does that give us? Well, obviously, actually, number lines are key in things like measurement and statistics. You need that understanding. But we were also looking wider. And this sort of notion at the bottom here, that the number line is a device for moving thinking forward, has come from work that Jeff Wake and Colin Foster have been doing in conjunction with some academics in Japan, and the way that in the Japanese curriculum the use of the number line is built in, that they use it as a device for moving thinking forward. That's what they think about. I think that's quite a nice way to think about manipulatives in general and representations, that we're using them as devices for moving thinking forward. And so that language, I think, is quite useful. So our research project, phase 1, which ran through the academic year 2018-19, involved teachers from 6 schools working with Stefanie and working with me, and we worked across a series of PD sessions. Stefanie and I ran entry and exit assessments, and we developed materials for the teachers to use with the children from EYFS through to year 6. And a lot of our sort of data that I'm going to share today comes from that project. So here's just a little bit of background on the schools and the children that were involved. On the left-hand side, you can see the number of children that we assessed in each year group. We didn't do assessments in reception. You'll see there's a big bulge in the number of assessments we did with year 2. We assessed quite a lot of children, as you can see. And on the right hand side, you've got the 6 schools split. And the reason we've got that bulge in year 2 is that we had 3 infant schools that were in amongst our group of 6. So you'll see there, look, 4 year 2 classes, 3 year 2 classes, 2 year 2 classes. With the year 1 pupils, we did the assessments in groups of 3 and worked with them so that we could really see what they were doing. But with year 2 classes, we ran the assessments with the whole class. So you know, there's some differences there. And then we also had 2 primary schools and a junior school. And you'll see that the teachers involved on the right hand side shows that we were involving teachers from right across the schools, because they became involved through the PD sessions and then working with children in the classrooms, but we didn't assess every child in each school. And then phase 2 was started last autumn, and so you'll realise why most of our data comes from phase 1, because like many things, phase 2 was interrupted by COVID. So we were working with 37 teachers from 20 schools across Devon, and working with 3 of us. So Helen Edginton joined the work on this project. And we used the materials we've been working on in phase 1. We further developed them in response to what we found out for both assessment and teaching. And the teachers ran the assessments with children, and we had the data from the entry assessments, but we don't have any exit data, unfortunately. But they were using the materials, the teaching materials we had been developing, and we have some feedback, but it's quite limited from phase 2. The focus in phase 2, as I said, we sort of refined the teaching materials, and we also looked at how they fitted with the national curriculum, because in phase 1 we were really focused on what do children understand about structured number lines and how can we support that understanding. But that doesn't exist as a separate bit within the national curriculum. So we needed to help teachers see where this was relevant to the work they were doing, and how they could feed it in and at which point they should feed it in. And we ended up with our teaching materials falling into 2 sections. One section was about using structured number lines to understand the structure of the number system. And then the other section was about using and applying that understanding in order to calculate efficiently. And I would say without a doubt that so far in both phases of our project, we've been much more successful in the first of those than we have in the second. And that link to calculation is something we have yet to really crack, I guess. And I think that's because there are so many other factors involved, but we'll pick up on that later. So I'm going to get you to do a little bit now. So if you've got a sort of a pencil or a pen and a bit of paper, I just want you to have a sort of a little think by doing some questions. And then I think that will give you quite a nice insight into when you look at what the children have done. So on your bit of paper, just draw yourself a number line that runs from 100 to 200 and mark 125 on it. And just notice your thinking and your decisions that are involved in doing that. I'll just give everybody a moment to do that. Okay, got a number line to look at here. Question is, which of the following is the fraction marked by the X on the number line? So again, just look at that and think about what's involved. Oh, do you first of all go for one of the answers and then realise actually no, that's not what it is? Are there assumptions that sort of happen when you're looking at that number line that you realise those are the assumptions children might have? Just have a little think about the 3 responses that are given there, A, B, and C, the possible fractions, and why the people writing this may have put those there. Could you solve that calculation? And again, attend to how you're choosing to solve it. And one final question, a second calculation for you to, again, solve that and notice how you choose to do it. And I want you to keep those things in mind as we start to look at what we found was happening with the children that we were working with, and therefore what became evident about the limits of their understanding around structured number lines, and how we sort of worked on that. So we're going to start by just really focusing on this, understanding structured number lines to understand the structure of the number system, this first part. When we wrote our findings from phase 1, this is what we wrote: that understanding of structured number lines does not appear as an explicit objective in the primary national curriculum. That is still the case. We are very aware that many teachers use number lines. One of the most common things that was said to us during phase 1 of the project was, oh, we used to use number lines, but we kind of haven't been. And that was very interesting, actually, that there was a general sense around from quite a lot of the teachers that they had been using number lines as part of maths teaching previously, but this had stopped for some reason. But when we interrogated them further about that, that was often about using number lines to do a calculation. It wasn't about using number lines to understand the structure of the number system. And so that was sort of something that came out. And when we talked to the children, you could see that it was, you know, most of their knowledge about number line was around counting. Now we've got the non-statutory guidance that have been issued this year, and in number and place value there is this strand that goes across which is about locating numbers in the linear number system. So this is a really good opportunity at the moment for us to get teachers thinking about the importance of understanding the structure of the number line as a way of understanding the structure of the number system. And this is, it's like a golden opportunity. And so the work that we've been doing really fits for this sort of attention that has come through the non-statutory guidance. So our assessing of all these children at the beginning, and I would say most of the statements that we make go right across the year groups, and I've got sort of, you know, different year group data in the report. We sort of pull out different year groups in the data and things, but often we were finding the same thing. One of the things we did when we did the assessments in the schools, so Stefanie and I went in and ran the assessments during a day, and then we had a staff meeting usually at the end of that day, and we shared the assessment scripts and what the children had done with the teachers. They usually sat in their year groups and they looked across all of them and went, the children don't understand this, or the children don't understand that. They could see it across all the year groups. So this is quite important, really, that the teachers themselves acknowledged where the limits of the children's understanding was, and it was actually very clear. And we heard that going across the different year groups. People would say, well, I've noticed this in year 3, and somebody else would say, yeah, that's exactly the same thing in year 4. So in general, this is a really key. Children had difficulty placing numbers, and because they weren't attending to the line itself at all, that the line itself has any importance, and that the space between marks are meaningful in any way. That is not where their attention was at all. They sometimes just viewed the marks on the number line as having nothing to do with this line. They're just, oh, that's where you write the numbers, but it's not the line itself. So this idea of it being a measurement model and the line representing that measurement model, and that therefore representing the number system, that's not where their attention was. There was an awful lot as well of counting in ones. I'm saying in an arbitrary way, the children themselves thought they were doing something, but they were ignoring everything already on the line and just counting to place numbers or identify numbers. And we'll have a little look at that. So here's a few examples. So that first one on the top left, that's a 0 to 10 number line. How irrelevant was the 0 and the 10? Well, the 0 was relevant. We started and we went 1, 2, 3, 4, 5. The 10 doesn't matter. There's a 10 there. I managed to fit all the numbers up to 28, so that's what fits there. So the idea that this was, you know, the 0 to 10 was meaningful. They just wrote lots of numbers. I think one of the things Stefanie and I were very surprised about in phase 1, we hadn't written anything in the materials for the teaching materials around this, was actually quite a lot of children didn't even understand the idea of the notion of marking the number line. So, you know, the child in the top one, they've written their numbers, they've written them in order, they know an awful lot. The idea that number line means anything and that you marking the numbers, that's not there. Again, on the right, I think that's a year 2, and you'll see where they've placed the numbers. They haven't marked the number line, they've just written the digits either side of the number line. So they don't have that sense of, just there's basically protocol here, isn't there? Or there's convention about them, the way their number line, we mark it and that sort of thing, and they didn't have that sort of understanding. And the child at the bottom has understood you need to do marks when you're doing a number line, but the marks are attached to the numbers, not attached to the number line, if you see what I mean. And so where the numbers start to fall down as you go along, the lines go as well. You also probably noticed something else about the one at the bottom. This was one of the year 1 children that I was sat with. His number line went from 0 to 10, and he started writing. And when he got to 8, he stopped and he said, I don't know how to write a number 8. And we were in a space with numerals around. So I said, can you find an 8? And then you'll be fine. So he found an 8 and he wrote his first one. And he stopped again and looked at me and he said, I think I need to write more 8s. And I thought he meant he needed to practice writing his 8s because he wasn't sure how to write an 8. What he actually had realised was there's a big gap here before I get to 10. And I know 9 needs to be at the other end next to 10. I'll just fill that gap with 8s. So that's exactly what he did. So again, there's you know, that sort of sense of the number line doesn't really seem to have much of a purpose, certainly not as a measurement model. So we did have to put into the materials, we hadn't expected to, these sorts of things where we're just looking at the convention of how you mark on a number line. Which of these has marks that actually work with the number line and mark a position, and which don't, and why not, and that sort of thing. Very easy to remedy, but we hadn't anticipated it. The biggest thing for us around this measurement model was about children understanding equal spacing, or not understanding equal spacing, because that's basically what the measurement model is, that the relation, you know, the position of this number to this number tells you about the whole number line, and it tells you about positions along the whole number line. So, you know, you've got an example at the top there where this is a 0 to 10. And again, it's a little bit like the boy on the previous slide. They've got so far and then they've gone, oh, it's quite a big gap. So let's just make 8 further away. Oh, we'll make 9 even further away because, you know, we've put things too close together. But that's okay. We've got our numbers in the right order and they've all fitted in. And even down here where we've got the 4-digit numbers, those positioning of those numbers, that's not very accurate or precise, is it? If you look at the 4,350, that really isn't in the midpoint. That's not the midpoint. So they know it's between those two numbers, but there's a real lack of attention to precision, which is another thing that came through when we were looking at positioning and understanding positioning. Plus, we had some questions about the position of 4,290 as well, in terms of, how is that really? When you're looking at 4-digit numbers, you're in year 4. What's your sense of that? Should it be a little bit more precise? And I mentioned there was this reliance on counting imaginary marks. And if you look closely at the top number line you've got here, this is a 0 to 20. It's got the midpoint marked and then a midpoint of the 0 to that midpoint marked. So what's the number? What this child has done is they have just counted and they've put little lines. You can see where they're counting if you look closely. So for them, it's 8 because they went 1, 2, 3, 4, 5, 6, 7. Oh, I've said 8 when I get to the arrow. And then similarly, you know, underneath where we've got a 5 in the middle, is that because 5s often go in the middle of number lines? I'm not sure. So we'll write 3 on the other one, but also, oh, now I just want to put in the other numbers and I'm going to count and I'll make them fit. So there's, you know, the fact that the first half of that number line is 0 to 5 and the second half of that number line is 5 to 20, and they're the same size. That didn't register. They were completely comfortable with that, completely comfortable, because there was no meaning in terms of the measurement side of things. There was definitely much, and you won't be surprised at this, a much greater understanding of horizontal lines and vertical lines. And these are a couple of classic examples when you look at what the children have done here, where they've placed the numbers between, you know, in the wrong section. So that 45 is actually beautifully in the middle of 30 and 40. So they've understood that sense of the positioning, but in the wrong section of the number line. Interestingly, I was in a call with some of the Shanghai researchers yesterday, and we were talking about number lines, and they don't introduce, they only do horizontal number lines in primary. They don't do vertical number lines at all, which was just very interesting. So our materials that we wrote to then support the understanding. So this equal spacing and the understanding the measurement model was absolutely key to every single year group. There wasn't a year group where this wasn't relevant. And we actually had to sort of go right back to basics in terms of understanding equal steps and marking steps, but mainly the equal steps with all of the year groups, and get the teachers to really engage with that. So you might be engaging with it in different step sizes in the year groups, but you had to really build that understanding of the measurement model. And I'm just going to take a bit of a focus on that here now. But those are the other things we then focused on in our materials, in this first sort of section of materials. taking 10 steps of equal size. So, for example, 10 to 20, having 10 steps and that sort of thing. Midpoints, and then points between marks. Let's let you read this quote from this. So I've really kind of summarised that already, but it resonates with things that Sue Gifford and others have written about spatial awareness and how important understanding space is in the early years. And I know many people in this call share my concern and our concern about the fact that the early learning goals don't have that element in there now. Of course, it's still in the curriculum, but it's actually really important. It's a really important element here. And Sue's identified some research here that suggests that developing spatial linear image of numbers helps children understand numerical relations, and this spatial reasoning is important to understanding that number line. So this is a really key part of it, and we realized as we were looking at equal spaces and equal steps that absolutely it's a spatial awareness thing we're looking at here, but what that gives you is an understanding of the relationship between numbers within the number system. So these two things are actually working together and really important. So I'll just give an example of the sort of thing that we did. Certainly in EYFS, who absolutely ran with this and loved this, we did a lot. There was a lot of teachers working on things like journeys. People going on journeys and their steps on the journey. One of the things you might notice is I'm saying steps all the time. We didn't do any hopping or jumping or have any loops, because one of the things we realized was that this looping takes your attention away from the line itself and the measurement model, but actually we're wanting them to see that line as being really important. So we were moving along the line and we were doing steps along the line. That all of our activities have that sense of moving along the line rather than jumping and missing bits of the line. We wanted that sense of moving along. So Hannah's Surprise is a great book for this, because she actually has an upturned bucket, as you can see in the picture, that she starts her journey from. So he's our 0. So we wouldn't have any numbers necessarily. We wouldn't necessarily have 0 there, but we're starting from the bucket. So she takes 5 steps and they're all the same size. So we might take 5 steps and put down footprints to mark those 5 steps. So you mark your own 5-step journey. You've got some footprints, you've got your starting place, you take 5 footsteps. Doesn't have to be in a straight line, but you're trying to get that sense of equal or fair. Fairness came into it. A lot of the early years and Key Stage 1 teachers talked about the children saying when things weren't fair, when they looked at a number line and the spacing wasn't equal. So that's the understanding of fairness. They understood that notion and they could apply it to the situation. So just really having lots of opportunity to explore that physically. Making your own journeys. Maybe it's a 5-step journey today, maybe it's a 7-step journey tomorrow. Footprints going down. Have you managed to do it? You know, so that there's a sense of that fairness. Can you follow somebody else's steps? When you follow somebody else's steps, do you feel like you're doing the same step every time? Do they feel equal? Are you happy with that? We did this sort of then drawing a picture of your journey, and you might start to add numbers, or you might start to add numbers when you put your footsteps down, and then add those onto your drawing as well. So we've got numbers coming in. So this is number 1, that's my first footstep. 2, got a bit of the language coming through there. Then this really fits with thinking about some of those sort of notions around executive function, but we're just making it slightly more difficult because you haven't got everything to look at and notice. Take a 5-step journey, but just put down the last footstep, footstep number 5. Can you then take that journey again and still do 5 equal steps and end up at that footstep? That's quite challenging. That's quite challenging. Can you take 5 equal size steps to reach your partner's footstep that they put down for their 5th step? So lots of exploring this, and you can see that the sort of little sequence here, it's increasingly difficult. I know one of our reception teachers, they were used doing stuff around gingerbread man, and so they used the gingerbread man running away in his strides. That was the steps that they did the journey of. And then we've got this whole notion here about what does the 5 tell us. So we've got this step and it says 5 on it. What does that tell us? We really wanted the children to be able to articulate that tells us that you've taken 5 steps from the bucket or from the starting place. It's the length of the journey you've taken, and that journey might be winding or it might be straight, but it is the journey you have taken, and that journey has taken 5 steps. So that five and that footstep with 5 on is marking the place on the number line, if you like. That actually at the moment we haven't got a line, it's marking the place in the journey, but it is telling you something about that journey, and that was really important. And then we might go on and consider steps taken by other people and other things. So we've got the chicken in the picture there. So would the chicken's journey look the same as Handa's? What would be different about the chicken steps? Oh, so we might have smaller steps, or we might have bigger steps. Maybe we've got a giant or something, or an adult, so their steps. So this slide shows you just sort of some of the ways that we developed that in the materials. The teaching materials have the activities and then have the sort of teaching narrative alongside it, the explanation of the thinking behind it. And we would do exactly that sort of thing, and they would put it into the teachers were putting it into context. Starting with that physical notion of it, we moved to using things like rods for children to then be able to replicate and make same size steps. So if you look here, we've started with doing it and placing 5. Then we use strips of paper to mark where we've got to across the rope or across the line. We've moved to a straight line now. This is sort of the major step here. And then the third section down, actually, you don't need to do the stepping. Here's a strip. Use that to do equal lengths to match a step size and to therefore mark fair spaces along there and draw your picture of the journey. And of course, rods, you can use those very well on paper to represent that sort of equal length. And so there's a lot of that exploration of that equal stepping and a lot of stopping and talking about, I'm on 3, what does this 3 mean? Why is this 3? Okay, it's how far from 0 to where I am now. It's 3 steps. I have gone, the journey I've taken is 3. So this is the sort of thing where we put in materials like this where, you know, which ones of these match what we've just been doing, and then you get the whole sort of calls of fairness and unfair, and you'll see we were mixing up horizontal and vertical, and we've got sort of sentences to say together. So each step is the same size, so each space on the number line must be the same size. So we're really trying to make that connection between the physical spatial experience and then what we're looking at in a drawing. And also there's then what the numbers are doing and where the numbers are and how they position and why they're there. So again, we've got examples and non-examples on here that we'd explore with the children. So from phase 1, the biggest improvement between entry and exit was around the second question, which focused on the understanding of equal spacing. And it was very clear to us that actually that's where the teachers had done the most work. It had resonated with them. They really understood it, but it also seemed to resonate. The children seemed to really make sense of that. And across the age groups, teachers realised they'd been making assumptions about what children understood about a structured number line, and that they needed to explore it to then get that number line to be useful to them in the work where they wanted to use it. And I've just put a couple of quotes at the bottom of this slide from some of the teachers. Okay. So we've looked at understanding structured number lines to understand the structure of the number line and this key notion of equal spacing and how that was really lacking for most of the children, if not all of the children we worked with. We also had this second sort of idea that if you understand the structure of the number system and how numbers fit into that, that should help you calculate more efficiently. And the number line and your understanding of the number line will help you to think about the numbers, not I've got to draw a number line to do the calculation. It will help me think about and understand, oh, this would be a good way to do this calculation. And if you think back to the questions that I gave you to have a go at yourself, 2002 subtract 1998, was it 837 add 6, and those two, that's the sort of thing that we were exploring. So one of the things that we found from phase 1 about not understanding the measurement model still was because they didn't understand the measurement model, they didn't understand moving from one mark to another. So for example, if you were looking at a ruler measuring from 10 centimetres to 30 centimetres, most of the children would say the length of that was 30 centimetres. They just read the end. They didn't have that sense of looking from mark to mark and this measurement. So these are taken from I think phase 1 and phase 2 assessments. So the question on the left was about ribbon. There's a ribbon that's got part of it's blue and part of it's red. How long is the red part of the ribbon? So given that, most of the children wrote 40. So if it's in centimetres, 40 centimetres. And then the one on the right, putting it in a sort of a data context, you've got the blue part of the bar shows the number of adults, and the red part of the bar shows the number of children who visited the Eden Project. How many children visited the Eden Project? 500. So that would be the sort of standard response to that. And here's a sort of a context where we were looking at actually, oh, we've got a broken ruler. Right, so how are we going to measure this pen? You know, how are we going to do that? So that was sort of one aspect of the children's lack of understanding of thinking about calculation, because they weren't actually making a connection from mark to mark. But we also had, this was an absolutely sort of key bit that we found, and ran right across the year groups again, that children relied on either counting or formal written method. It's almost like if you're a young child, you do your counting and there's a point at which you go, and now I'm just going to use the formal written method. And very few children were actually looking at the numbers and going, oh, those numbers are close together. That's easy to solve, and or things like that. Or I can partition the 6. So the decisions in calculation are not informed from our study. The children, they were not being informed by understanding of number and the number system, and that includes the position of numbers in relation to each other. And it also meant they weren't applying known facts to derive things. And there's sort of understanding of subtraction. And I said earlier that this section we didn't really improve on very much, and in some situations actually the children became even more reliant during the time of this project on written methods. And that's because the teachers didn't really get to attending to this. They spent most of the time on the project working on the equal spacing and the sense of the structure as a measurement model. But also because I think this is much more challenging, because there are notions about understanding of operations and relationships, and also ways of teaching methods that are all kind of tied in with this. It's not as simple as just thinking about the number line. I'll just let you read this bit. This is an extract from our findings in the report. I don't think our finding is going to be something that is a surprise to many of you today, that too many children are being expected to use a written method before they've secured understanding of the operations or how to use this understanding to solve calculations. But I think that quote from Russell is a really important one for us to hold on to and to share with teachers and you know, share widely in our schools, is that the growing evidence is that if you've memorized and practiced a procedure without understanding, it's really difficult then to put meaning into that. And that's a real challenge then, if that's what's actually happening for a lot of children at the moment. So we had more children solving the subtraction. All the subtractions were of the nature that you did. They were numbers close together like that. So the number of children who chose to solve that using a formal written method increased from year 3 to year 6, both in the pre and the post assessments. And the project didn't have a significant impact on the decisions they made. And for some children, there was an increase in the percentage of choosing the formal written method, probably because they had been taught about the formal written method in that year. Year 4 was the only year group there was a reduction in the percentage of children using the formal written method for subtraction. So one of our issues here, one of our findings was that the children were not choosing to focus on the gap between the numbers for subtraction, where the numbers were close together. That often led to a poor choice of method, often resulting in incorrect responses. And here are some of them. So I'm sure these won't be a surprise to you, but we're talking about numbers where to solve these mentally, it's really quite easy. If you notice that they're close together, know that you can think about a subtraction by thinking about how far apart are these numbers. And that's where we started focusing our attention in our materials. And you then apply what you know, your known facts So really that understanding of the number system. Little eye on the time, it's go on for much longer. One of the things that Haylock and Manning talk about is the fact that there's this real range of situations where we have to recognise that actually subtraction is appropriate. And so that's one of the challenges, and it's a challenge not just for the children, it's also a challenge for the teachers. And we found this in our, we did some collaborative lesson research cycles as part of the project, where we planned collaboratively with a group of teachers over a period of time, and then teachers from across the project were invited to the live lesson, and it was all sort of focused on thinking about understanding number lines to help you understand, calculate. And we took this very specific aspect that we've got a quote from Torben's here, that that you can solve a subtraction problem by thinking about how much have I got to add to B to get to A. That's particularly useful when numbers are close together. Their studies show that elementary school children seldom use that approach on 2-digit subtractions, even though it's the most efficient approach. So the evidence shows that children generally not doing this. When we worked with teachers in our group on this, we spent quite a long time together really wrestling with this. And really what we found was the most difficult thing for everybody to appreciate was the fact that there is a difference between the method I am using to solve a problem and the calculation I might write down to represent the problem. So we had a calculation in our lesson that was about the price, 2 prices of orange juice. One was £3.80 and one was £3.50. You had to do something to get one of those numbers, but basically you end up with £3.80 and £3.50, and you've got to find out the difference. And everybody was solving it by saying, well, just add on 30p. But we were saying, but the problem is, what's the difference between how much more? What's the difference between these two? Which one's a better deal? It was. So what's the difference? And the idea that we might write down £3.80 subtract £3.50 as a way of symbolic representing a problem that is about finding the difference, when the method used was adding on, was a real struggle. It was a real struggle for everybody involved in that. And we found when we worked with the children on it that they could solve the problem. The big difficulty for was they did not recognise that as being something that could be represented as a subtraction. What that means is when you're then faced with a subtraction problem, you're not going to know you can think about it as going, how close are these numbers together? And so that's the sort of real issue. The second part of this, and your second calculation question you did earlier, where you did 837 add 6, so that partitioning, quite a lot of children did not choose to partition and use, sort of well-rehearsed understand. They knew 6 could be thought of as 3 and 3. They could partition 6 into 3 and 3, but they did not choose to do that. They either counted in ones or they were using a column method. And again, you're sort of thinking, that this seems to be something that we that bringing that attention to, and there's a bit about understanding where 837 sits in our number system to know that it's 3 away from 840, and so that's the understanding we were working on in our materials. Yes, I'm just going to pick up on that. Thank you, Finley, about that comment there. Yeah, it may well be that one of the things is that addition and subtraction being taught as 2 ideas rather than a relationship. And we've talked about additive reasoning for quite a long time and those two becoming together. But I think there's also something about the way that people view symbols and their understanding of when you write symbols, what those symbols are representing. So if I have a problem that is a problem that involves difference, I can represent that by writing a subtraction. My method to solve it might involve addition. And I think it's that, and it's particularly around subtraction that issue comes up. I'll come to more questions like that in a moment. I'm just coming towards the end of this. So have a little read of that as well. So we've got an increase in the use of a formal written method going through Key Stage 2, even where this is something where mental method would be quick, easy, and it's using what you already know. It's using what you're going to use to do the written method. So it's just interesting. So we're suggesting there are huge implications about decision making, and making connections between known facts and different parts of the number system that come from this and from other research as well. It's hardly unique. And so our materials we did for phase 2 for this understanding calculation really focused on mark to mark, linking positioning to addition and subtraction. And then we looked at multiplication, division, and different steps of equal size. And again, that fits with some of the work that's in the non-statutory guidance, where we've got this strand of looking at different steps of equal size, like 2, 4, 5, and 10. That's exactly what we did, because it fits with a lot of measures and it fits with a lot of statistics. So, conclusion, and then we'll have about sort of 12 minutes or so left for further questions. The research project, incredibly revealing. We are pulling together a sort of a report as much as we can from phase 2, and we're going to add that onto the report for phase 1. But our phase 1 report is out and available freely on our website, and there'll be a link in this. You'll get the slides and you'll be able to access that. It certainly had an impact on teachers thinking about structured number lines and children's understanding, most clearly around this understanding of it as a measurement model. I think one of the things that's been most heartening is, as we've returned this term, we've had a number of people who were involved in our project last year, a number of our teachers wanting to access the materials, and we had been holding our materials in an NCTM community, and of course that community disappeared over the summer. And I think that itself is really nice, because they're already looking at how they want to integrate and build on that work this year. We have not really got to that point of making decisions when calculating with your understanding of the number system and your known facts yet. That's a much longer term goal. Okay, so there's a list of references there, and I'm just going to, I'll say one more thing and then we'll look at questions. I'm just going to flag up before I start looking at questions that our next talk will be coming up on the 22nd of October, and that will be around supporting active and influential participation through pre-teaching and assigned competence, more of our research. But it would be really nice if these sessions had some of your research in it, and just contact me if you'd like to do one of these. But I'm going to go over to chat now. Yes.